Let's look back at the lithium cobalt oxide battery for further analysis. In the oxidation half reaction in the anode, we can see that the graphite loses electrons along with lithium ions. In the reduction half reaction in the cathode, cobalt gains electrons and the lithium ions also intercalates with the cobalt oxide to balance the charges. If we analyze these two half reactions, we can see that the lithium acts as both the reducing agent and the oxidizing agent, because it promotes both the oxidation of the graphite and the reduction of the cobalt. Next, if we combine these two half reactions, a redox reaction is produced, which means that a lithium-ion battery uses the concept of electrochemistry to operate.
With our increasing energy needs, conventional lithium-ion batteries are just not enough to meet our demands. Silicon film has been attempted to replace the graphite anode in our current batteries because it can hold 10 times more lithium ions, which allows for more energy to be stored. The downside to this is that the film greatly expands when charged. Expansion and contraction of films results in pulverizing the anode, giving it a shorter lifespan. Luckily, the new innovation of nanowires solved this problem. At just a few nanometers thick, nanowires take in the effects of quantum mechanics. This new design of silicon nanowires allows for inflation and deflation with little pulverization. Also, since the wires are so small, more surface area can be achieved in a smaller volume, thus leading to a significantly more energy-dense battery. Silicon nanowires, like many other new and innovative technologies, come with even more societal benefits. Some of these societal benefits include lighter electronics due to being more energy-dense. This allows for smaller and lighter batteries to achieve the same capacity as a phone using traditional lithium-ion batteries. At the same time, this allows for longer-lasting battery life for devices of the same size. Although this new innovative technology is very exciting and opens many doors for mobile electronic devices, it also embodies environmental and health concerns like many other new technologies. One immediate effect we can expect to see if this new technology comes to market is the extra demand for lithium-ion batteries. Worry of water usage is already reported by the people in the lithium triangle, Argentina, Chile, and Bolivia, where most of the world's lithium is contained. A high level of water usage to harvest lithium may cut into already arid and drought-ridden areas where the brine is located. Additionally, lithium-ion batteries require graphite as a key ingredient. The increased demand in graphite only makes the situation in northeastern China worse, where graphite dust from mines and pines cover villages, leaving grit on food and making water undrinkable. This dust also has a detrimental effect of causing heart attacks and respiratory ailments when inhaled. Nanowires itself carry another new set of environmental problems. First, in order to produce the silicon nanowires, it would require more silicon and gold as a catalyst. Gold is already infamous for wreaking havoc amongst communities near its mines, leaching mercury and cyanide into local ecosystems as waste products. Resulting erosion, clogging streams, and rivers can eventually tame marine ecosystems far from the mining site. Other potential health hazards include the risk of the lithium battery exploding. If a battery gets hot enough, the electrolyte can ignite and explode. This can be the environment or a manufacturing error in the battery itself. An internal separator that keeps the positive and negative electrodes apart gets punctured. The battery will heat up when the two electrodes touch each other. This heat can ignite the organic solvent in the electrolyte and cause the battery to explode. Also, in smartphone batteries, the cathode of cobalt oxide can decompose to create oxygen during high temperatures. Combining oxygen and heat can result in a fire, especially if the electrolyte is flammable like diethyl carbonate. Luckily, most lithium-ion batteries have built-in protectors to prevent overheating to reduce the potential of any health hazards.
Created using Powtoon.